This is pre-AP Calculus. We're looking at Notes section 7.2. Specifically, we're going to be looking at graphs of exponential functions. And the concepts we're going to cover today, we've been covering these concepts the entire year. It's just a different parent graph. So a couple things. All exponential functions have equations of this form. Now, it's extremely important that you recognize a couple things right here. One, this right here is the inside function, meaning that affects the graph horizontally. The A and the K are on the outside. That affects it vertically. Now, there's a typo on this. It says that for this exponential function, the value of b is bigger than 0 but not equal to 1. We always want b to be bigger than 1. So just cross that out and say b has to be bigger than 1. For each of the following exponential functions, identify the indicated values in the information to complete the table below. All right, so first of all, number one, there's two things we got to make sure that we change if they're not written correctly. One, is b is 3 over 2, is it bigger than 1? Absolutely. 2, is the coefficient of x 1? Remember, we always want the coefficient of x to be 1. That's we've been doing that all year, our inside function. And if it wasn't, we factored something out. And something new, this base b, we're saying has to be bigger than 1. Does it technically have to be bigger than 1? No. But for the rules to apply the way they applied all year, we're going to always make sure that our b is bigger than 1. So to fix this function, because our base is right, but our coefficient of x is not 1, we're going to factor a -1 out of the top. So this gives us the new version of f of x. So what is the value of a? A is the coefficient, it's a number that you're multiplying by the base. So in this case, a is 1, because we don't see a number there. How does that affect the graph? It has no effect. If a is 1, it has no effect. What's the value of b in this? Well, b in this is the base. It's 3 over 2. We always want this to be bigger than 1. We always want b to be greater than 1. If it's not, we need to fix it, and we'll show you how that gets fixed. What's the value of c? C is what you're multiplying by the inside function, and for us, that's a -1. How does multiplying the inside affect the graph? It's a horizontal reflection. Remember, things that are on the inside affect the graph horizontally. What's the value of h? H is how far left or right you're moving the graph. It's always supposed to be x minus a number. We're subtracting 2, so h is 2. The graph is going to translate right to. Right is horizontal. And what is the value of k? This is our k value. It's -2. Things that are on the outside, the -2 is on the outside, it affects the graph vertically. It's going to translate the graph down too. Now I know at this point you have no idea what this graph looks like. We'll get to that in a moment. But right now we are reviewing these transformations that we've been doing for a long, long time. Looking at number 2, is b bigger than 1? The answer is yes. This is a negative that's being multiplied by a 3 that's raised to an exponent. The negative is not raised to the exponent. If it was, it'd be written like this. And that's not how it's written. If you want, for emphasis, to write this with the 3 in parentheses, you can, but the negative should not be in the parentheses. It doesn't make any sense to. So what's a in this case? A is -1. How does multiplying the outside of a function affect it? It's a vertical reflection. What's the value of b? B is 3. It's the base. What's the value of c? C is what you're multiplying the inside of the function by. We're multiplying it by 1 because we don't see anything that we're multiplying by. That has no effect on the graph. What's the value of h? H is whatever you are subtracting from x. We are subtracting a 1. So h is 1. That's going to translate the graph right 1. K is what you're adding or subtracting on the outside of the function. K is a 2. That's going to translate the graph up 2. All right, this next problem is our first issue. Here, the base is not bigger than 1. So how do we fix it? Easy, dear Liza, dear Liza. We reciprocate the base, and then we change the sign of the exponent. I'm not going to distribute my changing of the sign of the exponent because I want my lead coefficient. Let me rephrase that. I want the coefficient of x to be a positive 1. If I were to distribute it and get negative x plus 1, I'm going to have to factor it back out. So now, what is a? A is 2. How does multiplying by a number affect the graph on the outside? A positive number? It's going to cause a vertical dilation. By a scale factor of 2. So every y value gets doubled. That's what that means. Every y value from the original graph gets doubled. B is 3 over 2. C is whatever you're multiplying on the outside of the function. We are multiplying by a negative 1. That's going to cause a horizontal reflection. H is whatever you're subtracting from 1. H is a 1. It's going to translate the graph right 1. And K is a negative 2. That is going to cause the graph to be translated down 2 units. All right, number 4, we got 2 problems. B has to be bigger than 1, and the coefficient of x has to be 1 as well. So to fix this, I'm going to reciprocate. I'm going to multiply the exponent by negative 1. That fixes my problem. So A in this case is a negative 1. It's going to cause a vertical reflection. Or if A was a negative 2, be a vertical reflection, it would be stretched vertically by 2 as well. B is 3 over 2. C is positive 2. I'm sorry, that's not what C is. C is 1. So you're multiplying the inside function by. Has no effect. H is positive 2. It's going to translate the graph to the right 2. And K is positive 3. I'm going to change this here. It's going to translate the graph up 3. Last one. Got an issue again because our base is not bigger than 1. So we're going to change this. A is negative 3. Change the 1/2 to a 2. Change the sign of the exponent. I'm going to choose not to distribute it intentionally. So in this case, A is negative 3. It's going to do 2 things. A vertical reflection. And it's also going to stretch the graph vertically by a scale factor of 3. So we'll call that vertical dilation. By scale factor of 3. B is 2. C is negative 1. It's a horizontal reflection. H is -1 because it's supposed to be x minus a number, so it'd be x minus a -1. So if H is a -1, it's going to translate the graph left 1. Then finally, K is -1. It's going to translate the graph down 1. So let's make some generalizations from this. We're not going to do all the generalizations. We're just going to focus on A and K, and then I'll show you what one of these graphs looks like. The value of A. So these rules that I'm going to give you only work well is if B is greater than 1. And if the coefficient of x is a 1. So we got a couple choices. Let's say that A is bigger than 0. Conclusion we can make, since there's no vertical reflection, the graph is going to be above the horizontal asymptote. If A is less than 0, the conclusion we can make, the graph is below the horizontal asymptote. Forgot my is. Value of K. K is going to translate the graph up or down. And it's going to also translate the horizontal asymptote up and down. The parent graph for an exponential function has the horizontal asymptote on the x-axis. So the value of K is the value of the horizontal asymptote. If K is bigger than 0, conclusion we can make, the horizontal asymptote above the x-axis. If K is less than 0, the horizontal asymptote is below the x-axis. All right, I'm going to do a quick video. I'm going to stop this one. I'm going to make a video that you may or may not watch before this of what the parent graph of this looks like.